All right. Hello, everybody. My name is Arun Gupta. I work for Amazon, and I work in the open source team. So I work with a lot of service teams across Amazon to help define their open source strategy. And I understand today is the kickoff of IPL. So go RCB, yeah? So no slides here, by the way. I truly believe code is king. We should not be presenting slides at developer conferences. We should just jump into code and talk about code and live and breathe code, okay? So this is purely a GitHub-driven presentation here. I'm a Java developer. I was part of the original JDK team back at Sun Microsystems when we were doing JDK 1.1. So I got a lot of Java legacy heritage. I'm a Java champion as well. I talk about Java quite actively. So as a Java developer, how many of you are Java developers here? Dang, almost 90% of you are Java developers. That's a good sign. So Java is, no matter what you say, is the most prominent enterprise language here. And not just here, but around the world, as a matter of fact. But as a Java developer, we saw how Kubernetes is leading the mindshare in terms of orchestration. If you are jumping on your journey to become a Kubernetes developer, what it should look like, what are the tools I need to be familiar with, how would I get into that journey? So this is sort of my journey, a day in Java developer's life with a taste of Kubernetes, okay? So let's think about what those topics are. I only have half an hour. Typically, I take about 2 to 3 hours to go through this in detail, but hopefully this will raise your curiosity enough so that you understand what it takes for a Java developer to get started with it. The key part is bookmark this repo here, okay? So this is a repo on AWS samples. It's Kubernetes for Java developers. It's also available as a recorded course on LinkedIn. So if you go to linkedin.com, search for Kubernetes for Java developers. This is available as a course, so you can certainly subscribe for that as well. But let's see what it takes. Now, as a Java developer, we're going to look at our application. This application is very simple. It's a Spring Boot application. Likely you are building your application using Maven, Gradle, one of those tools. Hopefully you have a script. You're not going without a script. That's an important aspect. So we'll talk about it. As Dee was talking about earlier, the first step on your journey is really to containerize your application. What are my choices for containerization? Should I use a Maven plugin, Gradle plugin? Should I use Dockerfile? Zip plugin, lots of choices, so I'll talk about those. As a Java developer, Java is known to be heavyweight. So let's take a look at it. How can we make our images small? That's an important aspect, because think in a microservices world, your applications are scattered all across, and they could be downloaded at runtime at any point of time. So you don't want a big image size. That's important. Keeping your image size small is fundamentally important. So we'll talk about how you can create a quick image, particularly with features introduced in JDK 9 onwards. And I'll give an example of JDK 11. Then you want to build and test using Kubernetes cluster on your local desktop. So once you have done Dockerization, then you go on to the local testing part of it. How do you debug and test such applications using the usual tools that you're available for? IntelliJ, NetBeans, Eclipse, how do I debug my Kubernetes pods using those tools? Then, all right, I've done all that stuff. Now my application looks good. Next step in my journey is really to put it into the cloud. So I work for Amazon. There are a lot of other cloud providers who offer a managed Kubernetes service. So I'll talk a quick example of how you can get started with Amazon EKS, which is our managed service, and how you can migrate your application that is running on your desktop to very easily into the cloud. So it's a very seamless part of it. Once you have done that, then you're really looking at it, okay, application is up and running. Now I want observability across my entire application. In that case, I want to see that which service can talk to which service. I want to see if anything goes down. I want to see do canary deployments or A/B deployments. How do I do that across the applications? And last but not the least, I want to do maybe deployment pipelines. So feel free to go through this repo at your own pace, but I want to cover only the key topics today where it's important to understand, because most of the time when we talk to customers, the first thing they say is, how do I get started on the journey? That's the most important aspect, okay? Once you understand what the paths are, once you get on the journey, which is the Dockerization part of it, so we'll talk about that first. Well, let's quickly look at the application here. So if I look at my application, it's a simple Spring Boot application here. And if I look at my greeting controller, nothing fancy, just simple REST endpoint. you guys know to build far better, much more complex Java applications, so that's not the focus of this talk here. I just want to show what an application could look like and how would you Dockerize it, essentially. Now, in order to Dockerize it, what you can do is, if you're using, in this case I'm using Maven, so there's a tool by the Google Container Tools team, it's called as JIT. There are other Docker Maven plugins, one by Fabricate team at Red Hat, one by Spotify, but the tool that I like really a lot is JIT, and it works very well. So let's see how it works. So this is my usual pom.xml here. And I've specified the JIT Maven plugin in the pom.xml profile here. Okay, and in the profile, essentially what I'm saying is, I can do, the advantage of this is, I can do Maven package, and that'll give me a jar file, a fat jar file. Or I can do Maven package and give it a profile, then it'll give me a Docker image as well. And the biggest advantage of this is, I can use my Maven language, the language that I'm used to create my Docker image in this case. I'm specifying use OpenJDK 8 JRE as a base image, what the image name is going to look like, what kind of options I want to put it in there. Writing Docker files could be scary sometimes, you know. I mean, there are documents written around what are the best practices to write a Docker file. So if you are starting new with Docker, yes, you can start with Docker file, but then right away you jump into what kind of base image, how should I use it, you know, what should be my from, what should be my add, what should be my copy. Mind starts running around it. I'm a Java developer. Give me my Maven language and I'm happy with that. And that's where this tool comes in very handy. So it can easily build your Docker image using Maven language, push it directly to a Docker repository, or build it to your local Docker instance as well. Well, the other option is you can actually use a Dockerfile. And in that case, what I'm doing here is, instead of using a single Docker file, like, you know, instead of saying, hey, I'm going to build here, and then I'm going to run my Docker image separately, I'm using one file, one Docker file, and it's a multi-stage Docker file. And in this case, if you see line 1 is what it says Maven as a base image. And at the end of that line, it says as build. What that means is, that is really my build phase. And then my second phase starts wherever my second from statement kicks in. And in this case, my second statement phase starts from line 8. So what I'm doing is, in my first phase, essentially, I'm using Maven as a base image. I don't even need to have Maven downloaded. I'm purely using Docker as my build tool as well. So I'm using Docker as a build tool, and that allows me to run my Maven, you know, have my Maven repository, build my image. Because, you know, remember, when you build with Maven, it downloads the entire internet on your machine. That's not what you want in your image, though. So that's your phase 1. Phase 2 is where you say, all right, you know what? From the phase 1, pick up my jar file or my war file, and now use JRE as a base image. One of the big anti-patterns that we have seen in customer cases is where customers are using actually JDK as a base image. Do you really need JDK as a base image? Think about it. If you're using JSPs, if you need to compile at runtime, things like those where it matters to have JDK as a base image. Otherwise, switch from JDK to JRE as a base image. That's an important design pattern you want to think about, because it really brings your image size. You know, JDK and JRE difference is huge, particularly if you're using JDK 8. Now, if you're using JDK 11, then you can do other fun things. JDK 11 has these tools called as JDEPS and JLink. Now remember, Java 9 introduced the capability by which it has modularized the entire JDK. So it kind of split the JDK into multiple modules, and then what you can do is you can create JDK. Well, JDK 11 does not ship with a JRE, because the idea is you got to create your own custom JRE with it. So what you're doing here is, in this case, I'm saying take the JDEPS tool, which is right here. Take the JDEPS tool, give it to my target jar file, and give me the list of modules that it depends upon. In addition, also take the modules that Spring Boot is dependent upon. So now you're taking all of that together and using the JLink tool to create a custom JRE. And those are, by the way, standard JDK tools. Those are available whether you're using Amazon Corretto, whether you're using Oracle JDK, or any other distribution of OpenJDK. So both ways it would work. And now that you have created your custom JRE, you can actually get rolling with this. So if I go back to my application, so in my application now, or in my app, I have a Dockerfile.jre, and here I'm just saying, use Debian 9 as a base image. I'm having my base JRE generated in a directory. Then I'm using the Java or the JVM from that JRE and just invoking my jar file. What is the advantage? Well, let's take a look. The biggest advantage that you get as a customer, your image size shrunk from literally 490 megabytes to 162 megabytes. So basically, you are cutting down to less than a third of your image size. So always pay attention to what is it that matters to you, how can you cut down your image size, because that's what needs to be lean. It's not about disk storage, it's not about memory storage, it's about how fast you can download that image on your local machine and how efficiently you can bootstrap that image. Once you have done that, then you're looking at, okay, how do I test this file? How do I test this Docker image in a Kubernetes land? Well, the way you think about this is, the way there is Dockerfile, which kind of defines how the Docker image needs to be generated, you need to look at sort of a Kubernetes manifest. You need to understand, go to kubernetes.io, excellent piece of documentation over there, what different Kubernetes resources need to be created. It talks about pods, services, replica sets, deployments, all the basic concepts that you need to understand. And then what you need to do is you need to really create your Kubernetes manifest that generate those resources for you, okay? Now, you write the manifest files, you need to provide those manifest file to a Kubernetes cluster, which will basically create those resources for you. So how do you start a Kubernetes cluster? Well, again, there are multiple ways for that. If you're running, but my preferred way is Docker Desktop, because I have Docker running on my machine. That's how I create my images. So I just literally go to Docker Desktop. So let's go here. I go to Docker Desktop, and I say Preferences. And with a click of button, later, not right now. I go on this Kubernetes tab here, and I just say Enable Kubernetes. And that literally gives me a single node Kubernetes cluster on my machine. Very easy to get started with. That's one option, and I've seen that customers use a lot. In addition, you can of course use Minikube, and there are lots of other flavors and varieties that are available that gives you a single node Kubernetes cluster. But pretty much by far, Docker Desktop and Minikube are the two most prominent options that you have seen. Now, once you have Kubernetes running on your machine, then you have the manifest file. What you need is, you need to be able to talk to that Kubernetes cluster. And that's where kubectl, which is a CLI to manage your Kubernetes cluster, comes in. So you download the CLI, simple brew install on a MacBook, and then you say brew install Kubernetes CLI, and then you say kubectl, take this manifest file, deploy it to a cluster, and then it'll create the resources. What is the biggest advantage if you think about it from the Kubernetes perspective or developer's perspective? Let's say you say, create 4 replicas of my application, okay? It's gonna create those 4 replicas, and the biggest advantage is, it's gonna make sure that those 4 replicas stay up. If an instance goes down, Kubernetes has built-in mechanisms that brings that replica back up again. So that's the important part from a developer perspective, because then I can focus on my application as opposed to like, is my app running? Is it meeting the quality requirements? You still have to do testing and all those things, but your undifferentiated heavy lifting is done by Kubernetes for you. That's the advantage. The other part you want to think about is, when you are building a microservices-based application, it typically is not just a microservice. It's probably a bunch of microservices. As a matter of fact, it's not uncommon to have an application with 10 to 20 to even 50 to 100 microservices. That's very common, actually. Now, think about, and each of those microservices are scaling up and down. So step back for a second now. You're building an application, Java application, lots of different concepts over there. Lots of different Docker files over there, lots of different Maven plugins over there, lots of different Docker containers over there. How do I manage them as a single application? That's where Helm gets in. So Kubernetes Helm is a way by which you define and declare a Kubernetes application. Very easy to use actually. So just like you install kubectl CLI, you can install Kubernetes Helm. Then you, at least until Helm 2, this architecture is changing and evolving in the next version of Helm. But for now, at least, you can install a client component of Helm and a server component of Helm. And that server component is sitting in the Kubernetes cluster. Once you have installed that, then you write up a Helm chart, as they say, and then in the Helm chart is where your the Kubernetes manifest will go. So let's take a look at our Helm chart here. But before that, let's take a look at our Kubernetes deployment manifest. So this is my deployment manifest, and it says this is apps version v1. This is a deployment manifest. I can give it some metadata. I'm saying a single replica. I'm putting some more metadata. And Kubernetes creates what we call as pod. As opposed to using container as a basic primitive, it uses pod as a basic primitive. Now the whole idea of pod is pod can have multiple containers, but typically correlated. And by that what I mean is that you don't mean that you create your front end and the back end because they're related into the same pod, but like a sidecar container. You have one main application container, and then maybe other sidecar containers that are doing other things for you, say logging or security or service mesh, which we'll talk about in a second. So that's sort of the idea. Now in this case, my pod has a single container, okay? Now I'm looking at, okay, I got one manifest, but I really want my application to have multiple of such manifests. So how do I manage that? How do I templatize that application so that I have some sort of a consistency across all of those manifests in terms of labels, in terms of naming? So go to my app here, and this is basically my Helm chart, what I'm showing you here. Here's the top level chart.yaml here, which kind of gives some metadata about the chart itself. Then I go to templates, and in here is where my greeting deployment, which is my manifest, sitting over there. Okay, so this is my greeting deployment.yaml, and you can see I'm using some templating mechanism here. And once I use a templating mechanism, that can allow me to actually bring that consistency across all of my service manifests. Another important aspect to understand is you generally, more commonly, do not create the pod by itself. What you do is you say, deployment is a Kubernetes artifact, create a deployment, and then the deployment will create the pod for you, because you want to say how many replicas of the pod you want, because then deployment makes sure that that many replicas of the pod stays up. Okay? Now, pods are ephemeral. What that means is, pod starts up on a worker node, and it is given an IP address. But that IP address is not reliable, in the sense, if pod dies and comes up on a different worker node, you cannot refer it back. It may be given the same IP, but may not be given the same IP. So that's where what you do is you create this thing called as a service, which is a Kubernetes service. And that Kubernetes service says, I'm going to have a very loose mechanism. Pod is going to be given a label, and service is going to look for those labels. So if I go back here, I have my greeting service here. In my greeting service, I'm saying a selector tag, which is saying pick app release name dash greeting. And if I go to greeting deployment, in here, I'm saying app release name greeting. So it's a very loosely coupled mechanism, but that makes it that much more flexible. So essentially, you are needing a deployment, a service, a Helm chart, and here you go. You got your application infrastructure up and running. So then the next thing is really to get started with Kubernetes on the cloud. As I said, a lot of different cloud providers provide their managed services. We, of course, our customers use Amazon EKS all the time. What Amazon EKS gives you is a managed control plane, and you bring the data plane and connect to it. Now, if you look at our official documentation, it could like whoa, this is daunting. This is too challenging for me. But what we recommend to our customers, Weaveworks is a very good partner of AWS and is also a CNCF member. And they have written a tool called as EKS Scuttle. Just like kubectl, it's an EKS Scuttle. And EKS Scuttle really allows you to create EKS cluster with literally a single line. So let me show you how seamless it is. So if I go to, say, Kubernetes cluster on EKS on AWS, Here's the command that I'm using here, okay? So just that single line of code. And by the way, regions is also optional. I can just say EKS kernel create cluster, give it a cluster name, and how many nodes you want. By default, it goes to US West 2, but depending upon the region that you want to deploy it in, it's totally all right. So that's the way you want to look at it. I mean, EKS is available in about 12 plus regions across the world. So pick the region that is closest to you or closest to your customers where you want it to be provisioned, and you can create an Amazon EKS cluster very easily. Now the cluster is created, and your app is running on the local desktop. How do you switch the context from your desktop to the cloud? So remember we talked about kubekernel? Kubekernel can be configured to talk to a cluster because it has the security credentials, certificates, etc. that are needed to talk to that cluster. So you can say kubekernel config. So let me show the command here actually. So I can say kubekernel config get context. It'll show me all the contexts that are running or contexts that are available on my local environment. I may have configured multiple clusters. So I may have Docker for desktop, I may have an EKS cluster, I may have an EKS cluster, another one in a different region, and I would name them differently. So literally moving your application from desktop to the cloud is very seamless. All you say is kubekernel, use a different context, you change the context, and then you just redeploy the same application. And that is very seamless and enabled by all of these CI/CD tools that are available in the market. I mean, of course, we have a managed service called as code pipeline, but feel free to use the tool that works for you. Jenkins works for you, go for it. JFrog works for you, go for it. Circle CI, whatever tool works for you, whatever gives you that ability to just literally add those commands in there and automate it and script it, that makes it super easy. The last point I want to quickly talk about is, well, we didn't get to talk about the debugging part of it, but one of the things, if you recall, is if I look at my Dockerfile, in the Dockerfile, I have these things called as environment variables, okay, Java options. If I fire up my IntelliJ and I want to say I want to connect to a remote JVM, it'll give me those options. So I literally drop those options in my Dockerfile, and that's what allows me to debug my Kubernetes pod in production, in development, whatever way you want. And the last thing I want to talk about quickly is service mesh. Well, what is the relevance? I mean, Subbu talked about earlier today the relevance of app mesh. But what we are looking over here is, I have all these microservices deployed. I want a certain microservice to be able to talk to a certain microservice. I want to have the ability by which I can introduce a new version of a microservice and send only 5% of the traffic over there. Now, Kubernetes by itself does not provide that capability. Typically what you do is you have a deployment running with, say, 5 replicas, but now you want to send only 5% of the traffic. Now, 5% of the traffic, the minimum replica that you got to run is 1. And 1 of 5 is 20%. So you got to really scale it up to 20, and then you can have this deployment as 1, and then you can accommodate for that 5. So that makes it a little bit difficult for Kubernetes, and that's where exactly the concept of service mesh comes in. Service mesh really relies upon the concept of Envoy proxy, which is again a CNCF graduated project. And Envoy is injected as a sidecar, as we discussed earlier, to your pod. Now, imagine you have those hundreds of microservices spanning across your cluster. And for each pod, you have the Envoy sidecar injected. So that becomes your Envoy data plane. You need to manage that data plane, and that becomes your Istio control plane. Because you want to be able to say which service talks to which service, or if I want to do a canary, if I want to do a AB, if I want to do control groups, whatever you want to do, you can control that using the Istio resources. So I think we may be running out of time, but I would definitely recommend taking a look at this. This particular repo here. Also, as I said earlier, take a look at the LinkedIn recording. It's a deep dive course, exactly kind of walks you through the code samples and how it can be done. The last but not the least, send pull requests. This is an open source world. We would love to see pull requests from you. Thank you. I'll be outside for some more time. If you want to talk, I would love to talk and hear thoughts and feedback. Thanks so much.